Hey guys, welcome to day 17 of the Data Science AI Engineering Challenge which I have started. So today I'm going to talk about RNN. Okay, it is an extension of all the neural network what we have seen and as we have read. Okay, we have seen ANN, we have seen CNN. Right, today we are going to talk about RNN. What is the use of RNN? Why we have to use RNN and other stuff. Right. So before we start, it's me again, Mahesh, having 14 years of experience in data as a data scientist, data architect, data engineer, as a data trainer. Right, I'm going to talk about RNN. So have you ever thought about how does the algo traders technically predict the price of the stocks like Nvidia, Apple, and Tesla? Right? So technically, they are using RNN behind the box. We have also did one of the stock price prediction with the help of ANN, but this RNN would be much better than that one. I'll tell you why. Okay, let's go inside. So before we start, right, make sure that you have the basic understanding. What is a neural network? What is an activation layer? What is an optimization layer? Because these all things is going to be very important when you're doing RNN in RNN code. Okay, so I hope you go and see those videos. If you have not seen those videos, please I will put the videos in the description. Okay, now introduction to the RNN. So we have seen ANN. For example, we have seen ANN. ANN is nothing but if we give some kind of input, there would be an input layer, there would be a hidden layer, there would be an output layer. This hidden layer, technically what happens is that it does one level of backward propagation. Okay. During the backward propagation, all the hidden layers weights are going to get updated and make sure that the output is much more closer to the reality. Correct? So we have done multiple examples around ANN. So if you don't understand, go and see the videos of the ANN. Okay. So we have also did something called CNN, right? Where we have taken an image. We know that we cannot directly take the image input towards the ANN. We have to do some kind of processing. For example, a convolution layer, right? We give it to convolution layer with the help of a convolution filter. Then we give it to max pooling, and then after the resulting is going to a fully connected layer, which is nothing but an ANN kind of stuff at the end. Okay, then it goes and then the prediction happens of 1 and 0 kind of stuff, right? So this is something which we have learned about the CNN. Now, what is an RNN? So whenever we think about some kind of sequence, for example, time data, then sentences. So for example, time data, a stock data is a sequence. So basically there would be some kind of up, there would be some kind of down, some up, some down, and all that. But it is happening on the few days, like day 1, day 2, day 3, day 4. Right? So if you want to predict a price somewhere here, so if we have the analysis of all the past, it becomes very easy for us to do that kind of activity. Technically, that's what the RNN is, right? So if you want to understand what is RNN, so when we want to process a sequential data at a point of time, we use RNN. Okay, the order plays a very important role. Okay, so if you have a data set where the order plays a very important role, there's a sequence of data, something like time or something like sentences. Because in sentences also we have sequence. For example, if I say happy birthday to you, I cannot say you too happy birthday. So you cannot say that like that. The sequence plays a very important role to make a context around it. So if you're working on it around some kind of that kind of data, then you can use RNN for that. Okay. So that's what I have said here. So you can use RNN for using the pattern, language model, context matters. So these are the use cases for the RNN. Okay. So before I go ahead, right, I have given an example. I've talked about creating one example first. Okay. So let's say I have a X and Y. X is nothing but my days and Y is nothing but my low, mid, and high. So this is my low, this is my mid, this is my high in the day. Okay, this is my day 1, day 2, day 3, day 4, day 5. If I want to predict my day 4, let's say this is my data set what I have seen. Okay, if I want to predict my day 4, okay, and I have the data for day 3, I have data for day 2, I have data for day 1. So if I'm able to give this data set for some kind of prediction, that would be fantastic. That's what the RNN does technically. So it's very simple. So basically, if I want to forget about RNN, so what happens, we have an input, we have a weight, we have a bias, okay, which we give it to an activation function. If you remember any activation function, you can take a pause and you can tell me what activation function do you know. But here I've taken an example of a ReLU. Okay, then the weight comes forward, the bias, and the output comes into picture. It can be 1 or 0, whatever. Okay, but what happens in a RNN is that before we go ahead, right, the output of the activation function goes back to the sum. Okay, so now why we do that? Let's say, for example, if we are trying to predict what is going to happen tomorrow, right? So what we do is that we give yesterday's data set. Okay, the activation function comes into picture, it gives a weight, and before we go ahead, of course there would be some kind of output, right? But before we don't neglect that output, we go and give the output of the activation function to the next biasness, and we have today's data set. So the same process happens, and based on that it gives a prediction for the tomorrow. We can go ahead and do something similar. Like for example, if we want to give this data set to the next layer, that is also possible. If we have a day before yesterday's data set, if we want to go 3 level back, for example, if this is tomorrow, right? If this is tomorrow, I have yesterday's data, day before yesterday's data, day like t minus 3 data also. If you want to do like that, we can create a layer upon layer which gives max the output of the activation function to the next layer, right? If you want to do that, that is also possible. Okay, so remember that. But if we continue to do this again and again, right, then at that point of time there is something called a gradient descent issue, or you can say gradient boosting or gradient bursting kind of stuff happens, right? So I'll talk about that a bit more later. Okay, so I've spoken about that. So this is the applications of that. It can use like languages, it can use speech, predictive testing, and as well as the stock price. Okay. So I've spoken about the advantages and challenges of the RNN. The advantages is, for example, we have seen it captures temporal dependency, it has a very good variable that's sequencing out, and it does better predictions. Better prediction in sequence data. Okay, but challenge is the variation gradient problem, the gradient bursting problem, right? Difficult to learn the sequence. So technically we are somewhere around here in the RNN recurrent neural network. So there are few other algorithms which technically balance it out the whole problem of the RNN, the LSTM and transformer, which we'll learn later. Okay, so now conclusion would be go ahead and try to understand what is RNN. I'm going to come with the code tomorrow, right? So please do wait for that. If you have any problem till here, please let me know. I'm happy to help you guys. Okay, and do subscribe and do like the video. If you want to have something, if you want to talk to me, happy to talk to you. Thank you. If you have reached till here, it means that you have finished the video. Thanks for watching and being part of the 28 Data Science Challenge. Your support, engagement, and enthusiasm make this journey even more exciting for me. If you found this valuable, drop a comment, share your insight, and tag a friend who should join us. Let's keep learning, building, and growing together in the AI engineering space. Make sure to like, subscribe, and stay tuned for the next challenging stuff what is going to come tomorrow, because we have just started and it is going to get better and better as we go. Bye.